Okay, this is the last review. This is review C. Again, this is in preparation of our test. So again, they are not going to blatantly tell you what type of competency this is. That's kind of part of the deal, is you have to figure out how to decipher the problem. And most of it is dependent upon what type of standard deviation you have. All right, so picking out the important stuff of this first problem, I see that the sigma, notice that it's sigma, is 8.5. So it's a sigma problem, 40 match boxes. The average matches per box, excuse me, it's supposed to have an average of 40, I'm sorry. And we looked at 94, and our sample is, our sample was 42.1. But looking at a 1%, is it now more than 40? All right, so that says that the average that we accept is 40. Our average, however, is showing 42.1, and a standard deviation that is a sigma of 8.5. Sample size was of 94, and we want a 1%. Okay, so this is going to be ultimately a standard normal with a z-score because it's a sigma. All right, so the null hypothesis is that the average is 40. And the question is asking, is it now more than 40? So the average now is greater than 40. Again, if you're concerned, take a look. 40 turns into 42. So yeah, what's going on? So this arrow is pointing to the right. This is a right tail. Level of significance is 1%. All right, because this is a sigma, this is a standard normal. Which means we're getting a z-score. Again, to make this thing tick, make sure you have a complete numerator and complete denominator in their own unique parentheses. This is a z-score, so it goes to 2 decimal places, so that'll be 2.40. Okay, always look it up as a negative, so negative 2.40. It's not a two-tail, so the answer will be what it is. So 2.40. So negative 2.400082. We want to do some rejecting. Okay, this is a right tail with an alpha of 1%. Our alpha in this case is 0.082, so the distance from the edge is short. So we just showed that the p-value is less than my alpha. That means we reject H0 and accept H1. So I know that I'm sorry, back up just a little bit. I know that I wrote down that the null hypothesis is the average is 40, and the alternate is that the average is more than 40. Or it's greater than, I should say. So with that, I say exactly that, just in words. So reject H0, accept H1. So again, all I'm doing is I'm taking these symbols and putting them into place. So we reject H0, which says mu is equal to 40. So all I'm doing is I'm saying those in words, and accept H1, which is mu is greater than 40. Okay, this is a pure sample. Oh, let's see what they give us here. So they have a sample size of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a sample size. I want a 5%. They gave me an S. They say that the average is 30 minutes. Okay, is it? And then I want to know, is it less than 30 minutes? They said that the food will be there in 30 minutes. All right, so the average is 30. My sample average, oh, I did not get that yet. I'm sorry, I didn't get that yet. So I need to put that in my calculator. Okay, so I want to calc 1 var, and I see that my x bar is 28.8. My sample standard deviation is 1.8738. This was a sample size of 10 and an alpha of 5%. Is it now less than 30 minutes? Okay, so the null hypothesis says that the average is 30. We want to know, is the average less than 30? This is an S, so this is going to be a student's T. So numerator, denominator. Okay, so we go right to the p-value, and this is, again, built off of a t, so we have to use the t-table. That also means that we need a degree of freedom, which is going to be 9. Okay, so using the t-table, degree of freedom of 9, looking for 2.0252. So degree of freedom of 9 is that line that I underlined right there, looking for 2.02. 2.02 falls right there. This is a one-tail area, so we're not looking at that two-tail. This is a one-tail area. And so this is going to fall between 1.833 and 2.262. Okay, so that's where 2.02 falls. And then looking up, looking up, we see that they have p-values of 0.5 and 0.25. Okay, so this is going to be another liner kind of question. I think this was on the last review. What we do in this situation. Okay, this is a left tail with an alpha of 0.50. That's the alpha, 5%. Okay, note that the first one is 0.5, so that means it matches up with the alpha. So what do I do for which way does it go? Does it lean towards the do not reject H naught, or does it lean towards the rejection zone? And the other number is the determining factor, and I see that the other number is 0.025. So that means that the p-value falls to the rejection zone, the small side. All right, so that means reject H naught, accept H1. And so H naught was that the delivery time, the average was equal to 30 minutes. The alternate was that the average is less than 30 minutes. So we reject H naught, accept H1. Mu is equal to 30%. Mu is less than 30. So again, just deciphering what symbols are, just saying symbols in English words. Okay, this is the probability problem. Okay, so it's supposed to be 60%. We've said 44 out of 90. 1% has the mortality rate dropped. Okay, so that says that the probability itself should be 60%. Okay, that means failure, if it's living, yes, is 40%. We took a sample of 90 patients, and it showed that 44 of them passed away. And so that would be 40, sorry, this is R divided by N, so that's 44 out of 90. 48889. And then we want an alpha of 1%. Okay, these are probabilities. This is going to be a standard normal. Okay, right now the null hypothesis is the probability is 60%. That means that the alternate hypothesis has the mortality rate drop. So is the percentage of death less than 60%. That makes this a left tail and a level of significance of 1%. Okay, again, because this is a probability, this is a standard normal, and we're going to get a z out of this. Let's try that all over again. Handwriting is getting a little sloppy, sorry. Okay, so parentheses in this situation should be around all of the top and the inside of the bottom. The z-score, so it goes to 2 decimal places. This is not a 2-tail, this is a 1-tail, so I don't need to double anything. My p-value is based upon a z of negative 215, so that's exactly what I look up. So negative 215, again, you always look them up as a negative, even if they're not negative, and that's 0158. Do not reject. Okay, let's put that on the picture. So this is a left tail, then alpha being 1%. And we see that our p-value is 0.015, so that's bigger. It's larger. So it gets to that do not reject zone, that do not reject. So we see that our p-value is larger than the alpha, is greater than, so do not reject H0. All right, so that means we do not have enough evidence to say H1. H1 in this case is saying that the probability is less than 60%. And this is mortality due to extensive burns. Mortality due to extensive burns. So we do not have enough evidence to say H1. Probability. So that's the probability is less than 60%. It's probably working, but we can't say it. Like, we'd have to change up our criteria. So we do not have enough evidence to say the probability is less than 60%.